Yes.
Yes. Okay. So, hi, I'm Kensei. I'm going to talk about the Kubernetes resource management and behind systems in Mercari. So, I'm Kensei. I'm one of the member of Mercari Japan platform info team. And so today I'm going to talk about some resource management practice in Kubernetes in Mercari. So we have various attempts for optimizing the Kubernetes resource these days. So yeah, let's go into the details. So first of all, let's see our cluster situation for now. So Mercari is one of the largest marketplace app in Japan. Mercari is composed of more than 300 microservices in Kubernetes. And then almost all microservices are on the one cluster. Our platform team is the cluster admin. So, and each application team is using our provided cluster. Let's see the cluster size management. So let's say we have the cluster like this. So there are 7 nodes and 2 of them are empty, 2 of them are very low utilized. So probably we can move the pods and reduce the node like this. It contributes to the cost reduction, but what if the application team want to deploy another pod into the Kubernetes cluster? Then we need to create another node for new pod. Of course, we have automated way to do that. So this is the cluster autoscaler. It's the open source, and but we are using the GK provided one. So cluster autoscaler increases or decreases the nodes, like I shared, based on the demand of the resources from the pods. So when scaling up, it's checking the cluster has any unschedulable pod like this. And if it does, it creates new node so that they can be scheduled on it. And when scaling down, it's periodically checking if some nodes are low utilized, and if all pods on that low utilized nodes can be evicted, then it evicts all pods on that node and delete nodes eventually. So here we have trade-off between cost and reliability. So the more nodes the cluster has, the stronger the system become against the node failure. But the more money, of course, more money we need to pay. So what we want to do here is reducing cost while keeping the reliability at the same time. So GKE provides the options to decide which way the customer goes. So that options decides these behaviors of cluster autoscaler and the scheduler. First, so how cluster autoscaler deletes nodes during the scaling down. So if we think more about money, we need to delete nodes more aggressively. But if we go with reliability way, then we need to keep nodes to some extent to keep the reliability. And the scheduled behavior. So change the scheduler to prefer either high utilized node when scheduling or low utilized node when scheduling. If we go with the high utilized nodes preferred way, then it means like bin packing. So all pods tend to gather in the one node or specific number of nodes, and then we can delete another low utilized node. Then in Mercari, we choose the money option. So the cluster scale will delete nodes aggressively, and the schedule pods by preferring the high utilized node. But yeah, so as I said, so we need to keep the reliability at the same time. So we introduced some over provisioning pods, which means pods with the very low priority, and they will be killed when other workload pods, real workload pods cannot be scheduled. So at that time, so the workload pod will take place of over provisioning pods, and the over provisioning pods will be unschedulable instead. So cluster autoscaler will notice the demand of scaling up because those over provisioning pods is unschedulable in the cluster. So yeah, that works. Next, so let's see the workload size management. Actually, we have two strategies here. One is the horizontal way, and another is vertical way. Let's see the horizontal way first. So it's very simple overview of the flow of the traffic in the Kubernetes cluster. So when traffic came from customers, it goes through the Kubernetes service resource, and then Kubernetes, then each request goes to each pod. So here, the utilization is around 50%. So probably we can reduce the replicas so that it makes more high utilized on each pod. Then it's now 80% on each pod, but of course the traffic changes. When traffic grows, the utilization goes higher, of course. And then at that time, we need to create another pod again so that it can handle all the traffic. So of course, for this pod autoscaling, we don't do it by hand, of course. The Kubernetes community has the horizontal pod autoscale resource, which literally means horizontally pod autoscaling. So it scales down or up replicas based on the resource utilization like this. And so we only need to define the desired resource utilization on HPA. So let's say like this, HPA will keep changing the number of replicas so that the average utilization will be 60% in this case. So in Mercari, most of big workloads have been managed by HPAs. So yeah, probably around 300 HPAs in the product cluster, I guess. But HPA has, so we need to deal with some problems in the HPA. One of them is the merge container parts. We are using Istio to build a service mesh in our cluster. And so some parts have two containers, the primary one and the sidecar container. So resource type matrix, I mean this one, resource type matrix, calculating the resource utilization by taking the average of all containers utilization. So what if only one container's utilization goes up? Let's say the container A, the current utilization is, let's say, 10%, but another container current utilization is 90%. Thus, the average would be 50%. So with this definition, HPA keep trying to keep changing the replicas so that the average utilization will be 60%. So the scaling up won't happen in this case. But actually, container B almost runs out of the resources. So we want to scale up in this situation. So HPA has the new feature container-based metrics. So like this, we can define the ideal utilization on each container, but it's been alpha from 1.20. Currently, the latest version is 1.26. Actually, the alpha features in Kubernetes will so generally graduates to beta within the 1 or 2 releases. So it's very late. Actually, we are very waiting for it. So currently, no one working on the beta graduation actually. So we are working on the beta graduation so that it should be available on our cluster as soon as possible. Then what's the alternative for now? We are using Datadog metrics, which is the CRD created from Datadog. So we can define the Datadog query in the Datadog metrics CRD, and then HPA refers it as external metrics. As a result, it allows HPA to scale up or down based on the query result from the metrics value in Datadog. Probably, so it's gonna be like this. Datadog metrics, resources, and we can define the query. Then we can define, we can refer it from the HPA like this. So it means primary container CPU should be 70%, and yeah, still CPU should be 80% as well. So for more detail, we have a blog post for the Datadog metrics. So yeah, if you are interested in And the other optimization, so we had an incident related to HPA these days. So the upstream service died accidentally, and no traffic went to downstream services during the incident. Then the HPAs in downstream services scale down the workload, of course, because the no traffic reach at those downstream services. So the problem is when the upstream incident got resolved, the huge traffic came back. Then the downstream services was so downstream service needed to handle all the requests with the few replicas. So to prevent such an unusual scaling down, we defined the dynamic minimum replica number by the Datadog metrics again. So we defined the Datadog metrics referring to the replica number 1 week ago. So that it makes HPA not reducing the replica number less than half of last week's replica number. Yeah, that's it about the HPA. So let's go into the vertical way. So let's say we have two parts on the node. So each utilization is very low. So probably we want to change the resource amount on each part like this. But again, the traffic grows. So the utilization goes higher usually. Then we need to rechange the resource amount on each part. So its automated way is the vertical autoscaler. It watches the pod's resource utilization changes and store it as historical data. So, and from those historical data, it can calculate the ideal resource amount on each container and change the resource request on each container. Also, similar to it, we have multidimensional pod autoscaling, which is provided from the GKE, not OSS as far as I know. So MPA is actually not doing much, not doing the new thing. It just using HPA for CPU and using VPA for memory. So yeah, we have MPA and VPA on the table, but actually we haven't been using them yet. So we are running some experiment to evaluate all of our options and yeah, try to find the best autoscaling way to fit our use case. Other than that, we actually have the resource recommender. It's Slackbot. So periodically, so the application team gets the resource recommended value from the bot periodically, maybe once a month or something. It's like this. So currently it requested this amount of resources, but please change it this amount or something like that. So yeah, the behind the resource recommender, it using the VPA recommendation value actually. So yeah, so that means we don't directly using the VPA yet, but we use it kind of indirect way already. Yep. So that's all about it. So our next steps, as I said, we are now trying to find the best autoscaler on our cluster, on our most of Golang services. And other than that, we want to see the improvement in the HPA's performance. Currently, our cluster is very, very big, and actually, the number of HPA objects is very huge. So, if the controller takes more time to handle HPAs, then it affects our reliability battery. So we want to have some improvement on it. Actually, now even we cannot see the current performance of HPA. So in the upstream, we are now proposing the metrics feature in the controller so that we can see exactly the time the controller takes to handle one HPA object. Another one is the target value optimization. So currently, as I said, HPA allows us to define the ideal resource utilization in each object. So each application team has responsibility for setting those values. But we are thinking it should be done by some automatic way, like VPA does based on the historical data. Oh, okay. So it's the last slide from me. So yeah, thank you for listening my presentation.
Thank you, Kensei-san, for great presentation. So maybe like we will start taking some questions for this presentation. Yeah.
Hello, yeah, it's a great presentation. Good to see how you're using these things and getting around the issues that are there. So we call it jugaad in India. So the way you guys have done some of this stuff seems like jugaad. But I had a question about the resource utilization that you mentioned, the average. I was just wondering what is the
Sorry, that voice is not clear.
Oh, okay. So maybe like.
Yeah, I just wanted to know what is the average, when you are looking at average utilization, what is the time frame?
Yeah, you can.
I think Raju.
Raju, you are. You are or texting the question maybe faster.
Hello.
Hello.
Hello, I wanted to know what is the, when you are calculating average resource utilization, what is the time frame where you have set it up? Over which period are we calculating it?
Sorry, what are you talking about? Sorry, my voice sounds very.
Samposhan, can you hear us?
Yeah.
Is it okay now? Is it loud and clear?
Yeah.
Okay. So then how should I do it? How about now?
Yes, it's clear.
Okay, is it clear?
Yeah.
Yeah. Okay. So I wanted to know when you are calculating the HPA is calculating the average resource utilization, what is the time period over which that average is done? And is that time period variable based on our own measures?
So you are talking about the HPA's internal calculation algorithm. Am I right? Okay. So it depends on the how many HPA objects the cluster has actually. So because HPA controller so directly fetches the resource utilization value from metric server, and so it's like so it handles the object one by one, and when finish handling all the HPA objects, then it comes back to the first one, and then so like this. So when so the average is so it only takes the one value at that time, and then calculate the
So
calculate the,
instantaneous values and then calculates the average over all the objects. Instead of taking the average utilization of each object and then averaging that.
so average itself is calculated from the from the metric server. I mean, average of pods utilization is calculated from the metric server, and what the HPA controller does is taking all the pods resource utilization from the metric server and then calculate the average and scaling up or down based on that value.
So just a thought here, would it not be better to actually get over a time period an average and then figure it out how it is behaving? So to get a better utilization rather than looking at the instantaneous one?
Sorry, I can't understand. Can you repeat it, please?
I'm saying the way it is currently happening is that you are querying each pod for its instantaneous utilization and then averaging that.
Sorry, it has huge noise.
Okay. Maybe like you can come here. Do you mind? Sorry for that.
Sorry for many times.
Hello.
Hi.
I was saying that would it not be better to actually look at the average of the utilization of the pods and then get it so that the time effect is minimized? Because what could happen is that at one point of time, one of the pods could be serving something and that could give you a wrong instantaneous average value, which may not actually pan out. So you may basically, my worry is more on the fact that you may downscale the pod when it is not needed. So you'd have an issue bringing it up again.
Sorry, I didn't get it.
As you mentioned, the particular case you had, right, where if the upstream fails, then the downstream doesn't get the.
So this one?
Yeah. So in this case, if we're looking at it, may it not be better to, instead of looking at the instantaneous values, actually look at a previous measure and see how well the system was and prevent that and inadvertent scaling down. That sort of an issue I was talking about.
Yes, so we are preventing it. So such a unusual scaling down by the past values. Sorry, probably I'm not get your question clearly.
I think your question is, so let's say I'm calling a service and I'm a caller service, and now that service went down, because usually like I'm talking to that service and the resources are like appropriate. But once that service dies, actually the values from that service literally goes down. So for the upstream service, the scaling won't work. Anyways, it's dead.
Yeah, so that's what he's saying. So what happens is that when your resource utilization goes down, at that point, if you are trying to measure it, because the resources are
yeah, so this is
yeah. But I'm saying that instead of looking at the instantaneous values, over a period of time, the last 10 minutes or 15 minutes, what the average utilization has been, if you use that as a measure to what are the average resource utilization across pods,
yeah,
that may help us better prevent such sort of issues.
Yeah, exactly.
Instead of looking at each service at that point of time, because services are always in they are always in such right? Instantaneous value don't really make sense in this. You need some time period where you would say, what is that? And then that would also need to be tempered with time of day and all of that, depending upon how your behavior is, so that it could happen very much that at the peak, just before the peak, you measured and you found out that it was not there, so the calm before the storm, let us say, right? And then suddenly you get a flurry. And then you, by that time, because you're doing aggressive, what was to do? Yeah. So it will put down. So that's the issue with like Kubernetes HPA. So the way Kubernetes HPA works, it's like it doesn't take the past data into consideration. That's exactly what I'm saying. So when you, because you guys are doing this, all this stuff. Yeah. So, I mean, so this, I understand. So this is a problem essentially with the way Kubernetes HPA works. Yeah. So that needs to be looked at in a more configurable manner instead of. Yeah. So that's the problem we are trying to solve. Yeah. But you are trying to solve it. One way you are trying to solve it using the Datadog metrics. Yeah, Datadog metrics. Yeah. The other thing is you have got that pull request or whatever you guys have done as a request for the. Yeah, so Datadog metrics is like the reason we are using Datadog metrics is like HPA. I mean, now we can measure on container basis, but like if you go a little back, then the HPA measures the metrics based on pod. So if you have multiple containers in a pod, it averages out those. So that's not actually the right metrics to scale that pod. Exactly. So you need more observability. I think Kubernetes needs to build in more observability at the pod, at the container level rather than at the pod level, and then try to figure out how container. Yeah. So we need that intelligence needs to be. Yeah. So that's true. That's an open issue that I think. Yeah, it's an open issue, and like. But that's a good, interesting problem that is there. Yeah, and especially like overall, like Kubernetes is like eventually consistent. So there is no way you can scale your pods when there is like instant flooding. So let's say over the last week also, over the last month also, if your average traffic is like this, but you cannot guarantee it might not go up. So whenever it goes up, at that point, your services will fail to scale. So that means either you basically scale your cluster always scaled up. So that means like you're not using the resources. So the issue that we are having is that we don't have the scaling at a very, what we are trying to tout so much about containers and Kubernetes. Yeah, so it doesn't really work that well in practice. Yeah, so there are like several, one is the container level metrics, and another is the behavior, like the past behavior. If we can scale based on the past behavior, that is also one way. So there are like several ways, and currently that's a challenge we are working on. Yeah. So Samposhi-san, is that correct? Whatever I said.
So currently, I
Yes.
think the reason like we went using Datadog metrics was the container-based metrics. So that was the one reason. And now that is also not working well because the way Datadog metrics works is like it polls every 30 seconds. So that's very slow actually. So if there is a like sudden traffic, the services might go down. And once the service is down, then bringing up that service needs manual scaling because auto scaling, it's kind of like, it could be like deadlock. Yeah.
Yep.
So can you give us little insight on like how we are solving this instant request issue? So let's say this Datadog metrics works well on the 30 seconds window, but if there is a like instant request, sudden request, and Datadog metrics, because it polls every 30 seconds, there is a window in which it will take the average. But by the time we get that metrics, it's too late. So any insights on like how we are solving that problem?
Actually, we or everyone has not has no perfect way to solve it. Actually, HPA just checking the so regardless whether we are using Datadog metrics or not, we are using the container based this one built-in container based metrics, it cannot realize the spike, of course, because the metrics server itself is just scraping the resource utilization by certain seconds. So it's same as what the Datadog metrics does. So dealing with such spikes is very difficult problem in the with the HPA. I think it's
yeah. So I think it's a like open problem which
yes,
no one has perfect solution. And usually the companies which have like smaller cluster, so they don't face these issues because everything is working well. But with Mercari, like you have seen, we have like tons of services and our cluster is like now very big. So we are facing these issues. And so, yeah, we are trying to solve.
One more question.
Yeah.
As I understand, you are basically 8.10.
Oh, we are completely cloud. We are on cloud, yeah, GCP. So yeah, GCP. So we use, yeah. Yeah. So in terms of scaling the nodes, we don't have any issue. So it's just we need the right metrics to scale at the right point. That's the issue we are facing.
That you don't over provision and pay people more than it needs to know.
Yeah. So either we scale up all our services, we know, okay.
Yeah, I mean, that's crazy.
Yeah.
The way they cost, actually they cost a lot.
Yeah.
Cloud isn't really cheap.
Yeah, it's not cheap. It's like convenient, but not cheap. Because if it's on-prem, let's say, if you like hit a limit, then you need to add those servers manually.
Yeah. So I agree with that point, but cloud isn't cheap is what I have said.
That's true. That's true.
Get into that assumption that it is cheap. It
No,
really is not cheap.
It's convenient. Yeah.
It's cheap when you have a couple of servers. But many companies are actually moving away also. Many times it might, if you have the resources, my whole point is there are two types of resources. One is people who can actually manage the servers. So if you are in touch with a competent guy who can manage hardware, the data center, and you can contract it out to a couple of servers, that portion is taken care of. Then the other people to do all of that stuff, well, again, that is an investment that comes.
Yeah, and it's a continuous investment because you need to keep those members. What if they leave?
For example, an e-commerce application where the traffic is unpredictable, you can actually work out very well with B2B because you know that the traffic coming in is actually Monday to Friday and it will be quite stable.
Yes, I mean, what I'm saying is that I have this idea that the cloud as a whole is a great, but I think lots of case-to-case basis it might. For example, storage is really expensive. That's what I mean. Storage is keeping a few gigabytes of data isn't cheap. I mean, I was running a machine and I ran, which was not doing anything, a very basic Linux machine on Azure, it ran me up a $10 thing. And actually, I have a few machines, people are giving me VPSs in the cloud, which I'm paying, I think 4 GB, 40, 50 GB data storage or something. I'm paying $40 a year for that. Yeah. Yeah, that's what I'm saying. I'm paying in a VPS, but Azure charge me for a much smaller machine, they charge me $10 a month.
This solution, no.
This solution is expensive.
Yeah, it is expensive. I would like to know the VPS.
I will tell you that. Then there's Ramnode, which actually are very cheap.
Yeah, we can keep that there.
Like OpenStack. Pretty good service, which is one is Ramnode. They have a OpenStack.
Or a file.
Okay.
Yeah.
And 4 GB.
Only that I can, if it's cheaper, I'll have to look it up. I think it's called Windows replacement because it's a better box.
Okay, so
Low-end box actually, that site is low-endbox.com. So they have a lot of listing
I think the
of
next
boxes.
presentation is from Rafael. Okay.
Yeah.
Yeah, sorry, actually there is some issue with the logistics, so because the mic is separate.
Okay, so what do I need to do just to share my screen?
Yeah, you can share the screen and start.
Okay. Okay. Okay, can you see my screen now?
Yep.
Great. Okay, then yeah, I think everything is ready now. So hi everyone. Thank you very much for watching this presentation. Today we talk how to safely navigate the long, wide river that Istio is. So my name is Rafael Fries. I'm the engineering manager for the network team at Mercari in Japan. And today we will have a quick introduction on Istio at Mercari and two main sections. The first section will be about stabilizing Istio, and the second one will be about adopting Istio. Okay. So first of all, Mercari is a Japanese C2C marketplace where people can sell used items. We're based in Japan, in the US, and we have now a center of excellence in India. And for Istio at Mercari, so basically we have around 300 microservices with one namespace per service. We have around 100K RPS at peak on our API gateway, one main production GK cluster running on DCP, around 12,000 pods, 750 nodes. Those are values from maybe 2 years ago. So I think it changed a lot again recently. And in Mercari, so we started to consider Istio in 2019. We started a POC and we got a production release 5 months later in September 2019. And in February 2021, when I first did this presentation, we had around like 25% production services, 50% development services migrate to Istio. Now I think we are maybe around like 40 and 75, and we hope to have all services migrated by end of this year. Then regarding the features we use, mainly we use HTTP2, load balancing, traffic shifting, MTLS, and we also want to use retries and circuit breaking. So that's all about what we are doing currently in Istio, and I think Raju has also a presentation to explain more in detail some aspects of how we use Istio, but I will go into the more general lessons learned over the past few years of operating Istio.
And the first thing is about stabilizing Istio, because actually Istio is not stable or stable enough, because it has been kind of a hard complicated component that needs to mature, and it took a lot of time to maturing. It's now mostly mature, but there are many issues that we need to think when we run it in production, especially at scale. So I will explain quickly first the specifications of the Istio sidecar proxy to understand how and why we had to stabilize it on Kubernetes. And after that, we'll explore an important question we wanted to ask ourselves when we started Istio. Then we will explain how a full mesh is kind of utopian to have and the importance of knowing only what you need. And finally, we will briefly explain about some guardrails for Istio. So for the Istio sidecar proxy in a Kubernetes cluster, so to explain the concept, I will explain how a pod is working in Kubernetes. So we have now one pod and two containers, an application container, a sidecar container. And basically with Istio, all incoming traffic must flow through the sidecar first when entering the pod so that Istio can intercept and apply specific logic. And also, it also requires that all the outgoing traffic flow again through the sidecar before leaving the pod. So this brings an issue when the sidecar container is not ready, because basically what happened is that we have our definition of intercepting all the traffic. And if your sidecar container is not working or not running, then the traffic is sunk into the void because there is no application to listen to that. And same thing for the outgoing traffic. The app container will send it to the local sidecar container that is not ready, and same, the traffic will be void. So there are huge issues, especially in rollout, when we change our deployments, we roll out new pods, this kind of thing can happen. So we need to really make sure how to improve the reliability of the lifecycle for the containers in our pod. And first, we need to make sure that then Envoy is started before any other container in the pod, but it's also stopped after any other container in the pod. So we explained quickly the Istio sidecar specifications, and the next step is to understand what are the shortcomings in Kubernetes with sidecar containers. So in Kubernetes, a pod is the atomic unit on the scheduling, and the containers are not. So Kubernetes is by default not really good at handling a pod with multiple containers. And we need to, for Istio to work really seamlessly, we need to control the running order for containers, but there is no clear control API to customize the container lifecycle. And actually, there is no official way to instruct a pod to both start the sidecar container first and stop the sidecar container after the app container stopped. But we can wrap a pod lifecycle using a container lifecycle hooks to achieve our goal instead. And this is how it looked like. So the workaround consists of using a lifecycle hook, one called post start and the other called pre-stop. First, we ensure that Envoy is started before any container by setting the post start lifecycle hook in the Istio proxy container manifest. And basically, it will delay the next containers from running until the command that is executed exits. So this command is embedded natively by Istio in their image, and it make sure that the Istio process is ready until the pilot agent exits. And it's working very well. We have been using it for a long time. And it's pretty great. And also in the past, we had to do it manually by ourselves. But since Istio 1.8, there is a native setting in the configuration of Istio under mesh config. If we set hold application until proxy starts to true, it will automatically do this behavior for us. The second part about stopping envoy after any container is done. We use the pre-stop lifecycle hook. So here it's a loop that will check if there is any existing connection going to the proxy, and until all connections from the application are purged or properly terminated, it will stay. It will keep the Istio proxy alive. So the end result is that the application container drains all their connections, and once it gets to 0, then this command exit, and we are sure that the proxy terminated after the application container. Then there is another variant. We use one more command also to handle container restart cases, because we got some issues sometimes when containers were temporarily failing, but then when they come back to live status, then they will stay in that draining mode forever. So we also try to roll back their state to a listening state. Yep. Then we also need to make sure in the pod termination lifecycle that the termination grace period seconds need to be more than the sum of all the sleeps in the pre-stop hooks. Because in Kubernetes with termination grace period seconds, when this period ends, the pod will be entirely terminated. So if there are still connections at that time, they will be cut in the middle. So that's also where we want to make sure this lifecycle has enough time to be working appropriately. And yeah, that's one of the biggest, I would say, trick with Istio in production, is that it happens a lot if anyone is not configuring properly those hooks or forget about this termination grace period seconds. It's very, very easy to have like 5xx on rollouts. Yeah, so this is workaround. They are not like clear solutions, because as I say, Kubernetes doesn't really handle natively the container lifecycle within a pod. So you need still to test it appropriately and making sure that it works for you, because the timings will change depending on your workload. And hopefully when Kubernetes officially starts supporting the sidecar pattern, we don't need this kind of workaround. But unfortunately, it's still a far future. I thought like 3 years ago that it would be in few years, but now we are in 2023. There's still no big hope of having it. So yeah. Then the second shortcoming is about auto-scaling multi-container pods. I think Samposhi Ho-san explained very well what are the ways of scaling HPA and VPA with the custom metrics. But basically, we have the issue with multiple containers because we cannot really scale. We don't want to scale the same way depending on the proxy consumption or the application consumption. But Kubernetes is pretty dumb by default by averaging everything. I will skip quickly this part because I think it was very well described in the last presentation. But basically, we need to think of the two containers. And if we don't use custom metrics, container-based custom metrics, we need to think of the common HPA configuration. So I will skip this part. So the next thing is we need to understand if we are prepared to handle Istio, because there are many people that are thinking of introducing Istio in their company. Maybe they have a small scale, it looks good, but you need really to think about a lot of things, mainly 3 parts that are the main time consumers with Istio. The biggest one is really the troubleshooting, because you add so many proxies, so many layers in your infrastructure that you really need to be very good at debugging, at understanding the network protocols, how the requests are being handled, transformed, interpreting the errors, the network errors to understand where is a root cause. It's very difficult to have this when you have envoy configurations with like 100K lines of configuration or 1 million lines of configuration. That's very, very hard. The second thing is spreading adoption. So evangelizing, sharing the knowledge, convincing the business, convincing users. The human interaction with other people is the hardest thing in tech. So adoption is very, very hard. So you need a very good plan also on adopting and very strong support to achieve it. And last thing is supporting new features, because you need to learn, you need to master, you need to abstract those features, and abstracting especially, it requires a lot of mastery and understanding to have a good abstraction that will not be limiting you. So it also takes a lot of time. Also, for some advices of what you can do to have a more successful adoption. So the first thing is to have dedicated resources for it, like people that can really consistently take a look at it, understand, be better at that, and be able to handle basically any issue that potentially happen. I said earlier also about networking knowledge. It's very important to be knowledgeable about Linux, Kubernetes, networking, and Envoy. Also, we are very conservative on the way to expose those features, because basically once you expose something, you cannot take it back. So you need to be very patient and understanding how much load will come to you if you start opening many features in the Istio very large feature set. And finally, you really need mechanisms to improve the reliability of Istio, having rules, processes, abstractions to make sure that these, like one mesh that is spanning across everything, is not being vulnerable to anyone having a configuration issue. Then one of our advice is to choose the fights and starting small, like simple features such as just injecting the sidecars and start to have some HTTP2 based load balancing that you cannot have in the default Kubernetes clusters, or kind of traffic shifting for canaries, so that you can have an easy way, controllable way of releasing new features or new versions of your services. And once you build confidence in the system and the understanding of Istio, then you can onboard users, getting feedback, improve, and having this cycle iteratively. Then the other big issue that we have with the stability of Istio is that the service mesh itself, as a pattern, it means that like all your workloads are in one mesh. But the reality is that it's very hard to have everything under the same mesh. And the reason is basically that the control plane is having a lot of issues when you have lots of services to update for hundreds or thousands of proxies. There is a lot of communication costs between the control plane and the data plane. The proxies are also OM killed because they cannot handle the change frequency. There is also CPU throttling and like using CPU even without traffic, just because of this configuration management. And the Envoy configuration files are also crazy big, we have some files that are like 500K. It's totally crazy. It's not human readable at all. So it's a crazy hard task anytime you have to deal with manually checking the configuration. Thankfully, there are some ways to have some analysis, some parsing tools to find some more answers more easily, but still you have very, very big confusion files, and there are limitations around that as well. So to be honest, it still works very well at small POC level when you don't restrict anything. But when you start having some scale, and it's even like small to start of medium scale, when you have a lot of configuration objects in your mesh, you will start having all those issues. And the only way to bypass that is to use namespace isolation mechanism, so that you can only share to a given proxy what it needs to know, and only what it needs, not the entire mesh configuration, but just from where it's called and to where it needs to call something. And in Istio, it takes the form of a CRD called sidecar. So it's a bit tricky because sidecar is overly used, unfortunately. But this sidecar CRD, it allows you to control the exposure of the mesh configuration. And so here we can see we only allow the local proxies, local namespace proxies, and also the Istio systems ports to get the configuration from them. So it limits a lot the amount of configuration that will end up in the proxy. Yep. And those are like the listeners, clusters, endpoints mainly that are affected by this trick. And this is the biggest change, actually. What happened when we didn't have the sidecar CRD and when we had it. So you see there are a lot of spikes when we don't have a CRD, because the frontal plane is always taking the configuration changes at a variable interval. But it's crazy spiking to 3-4 calls very consistently. And once we have the sidecar CRD, it never spikes almost. Like, it's crazy low. It's within 500 millicores. So it's totally different. And it means that also in terms of cost for you, it's totally different as well, and for stability too. But the main drawback is that services must know their dependencies, document and update them. And if you don't have these habits, it's hard, because then Istio may feel not welcoming, because you need to have the clear dependency management configuration alongside with Istio. And what happens when you don't have a dependency in the allowed list of the sidecar CRD is that the service mesh features will not be available for that traffic, because Envoy will consider it as a pass-through cluster traffic and will not apply any filters on that. So you lose all the benefits of having the sidecar injected. And we have some approaches to handle it. First is not exposing the sidecar CRD to users. Use a service definition to generate the sidecar. You can also use a protocol-specific traffic sniffing, for example, gRPC call discovery, to find out the dependencies and try to generate the configuration. And other option is, more recently, Cilium is very, very popular now, that we can have some ABPF listening to see what kind of calls are originating. That's something that we'd like to investigate in the future. And in our case, we use the first approach because it's protocol agnostic and it works before having the live traffic, which is not the case for traffic sniffing that requires you to already have traffic flowing and until understanding what kind of dependency you have. So last part of the stabilizing section is about guardrails. So actually, I said the service mesh is common to all users. and any change to it spreads across the whole mesh. So it means that any misconfiguration will also spread it, even if you don't really want. And we as professionals, of course, we try to always minimize our errors, but we know that we are humans and we are error prone, and it means that ultimately error will always happen, and with a large blast radius, especially when we have something that is spanning across all your infrastructure. So how can we mitigate those errors and their impact? Two things. First thing is leveraging linters with conf tests to catch the issues at the CI level and having a short feedback loop. The second one is to leveraging admission webhooks, for example, OPA gatekeeper to protect the resources, and checking what cannot be checked at the linter level, because it's still, for example, inventory is only in the cluster, it's not in the linter level on the CI. So there are some layers that cannot be seen at the linter level. So it's kind of a difference in depth. And I did a presentation, not last year now, it's been maybe 3 years already, but it's still very, very relevant. And we still use those guardrails every day at Mercari. So I really recommend looking at this presentation in addition. So the takeaways are that Kubernetes doesn't handle sidecar containers well. We need to use post-start and pre-stop containers hooks to gracefully handle the lifecycle. We also found out that Kubernetes doesn't scale the Istio-enabled pods well, so you need to use the container resource to fix the HPA on the application container. Or there are other ways. We can go with that now. Then we need to only start exposing few Istio features to help us with the stability adoption. Using the sidecar CRDs to keep Istio healthy and find mechanisms to handle it automatically. It's very important. And finally, the guardrails are crucial to ensure the long-term stability of Istio. So that's it for the first section. So the second section is about adopting Istio. So it is very important as well. And that's where we have hard time, because it's been 4 years, I think, we tried to adopt Istio to all services, but there are many blockers that prevent us really to go straight away to a full adoption. So I try to explain what are those challenges. Basically, the first one is about moving HTTP2 load balancing from client side to Envoy. So in our case, we use gRPC very heavily. For the past 5 years, our platform is really gRPC native. So everything is communicating through gRPC, but Kubernetes is not good at load balancing it. Actually, it doesn't load balance it. So we were using client-side Golang based load balancing library and using headless services to get the records for all the destination services. And for us, headless services are kind of what cluster IP services are to common people. And kubedns is really not happy at all with SRV requests that are generated by headless services. And we had a lot of DNS troubles as well with overusing the headless services. So, and when we saw Istio, we thought, yeah, it would be great. We can use it for our HTTP2 load balancing capabilities out of the box. And we tried it with the gRPC services, but the result was that we got a lot of weird 5xx on the upstream service and pod rollout. And even when we handled a good graceful termination, Istio would definitely make the headless services worse. And so we didn't have any other choice than to stop using headless services. So we gradually migrated to cluster IP services. And when we migrate services, it's very difficult because services, they are immutable. And for each service migration, we need to have several steps that compounds to hundreds of services. So it's a big cost. So we need a very good strategy to make this kind of change. It's 4 steps to have a strategy for migration. First one is abstract, making abstractions that roll out behind the scene changes. Second is to explain the change to users and the motivation behind it so that they can really understand the reason. The third is supporting to facilitate the service owners by preparing for the PR, massive PR campaigns for Istio-enabled services. And finally, tracking to keep the inventory of the services by status, who have already a cluster IP service available, who has Istio-enabled, because if you don't track, then you don't understand where you are. And there may be some issues when someone is thinking they are good, but they are not. So it's important to track as well. Then the next adoption challenge we faced was the label selector updates for the app and version labels. So I don't think that you use app or version as a generic way of tagging or labeling your deployments, but basically labels, you need to change your deployments when you put labels. And the reason that we want those labels is because we really want to have these kind of traffic shifting features. And Istio, at least for the old version, the legacy version, I think Gateway CRD now, it wasn't available 2 years ago, but Gateway CRD now may have a different way, but you still have those app and version that are required for your deployments. And the issue is that when you want to update the label selector, since KDS 1.16, you have this field is immutable issue on the label selector. So it starts getting a lot for just having Istio. And many people think, okay, Istio is just about, yeah, I will add sidecars, everything will be working. But we just saw that now we have like headless services, we have labels. We need to think how to migrate all our services, having the consistency of putting those labels, creating the appropriate services. So it's not very difficult. So there is a step to do it, like 4 steps to change the labels, but it requires you to have a new deployment, making sure that the service is serving both deployments, and then creating the HPA to target new deployments and then deleting it. And you need to have this process from hundreds of services, so it's very tough. But we can have more sustainable approach, such as using the CD tooling like Spinnaker to automate this migration, ask users to use that migration pipeline when onboarding with Istio. So also Canary release can help a lot there, because Canaries is a feature you want in any case. So if you are able to have this kind of Canary release for the app and version migration, that's a way to save time. Then it was not the last issue that we had. Actually, we had an issue, but actually it's resolved. So I updated the slides a little bit from my presentation 2 years ago, because Istio has a default retry policy, and by default, like all HTTP requests mostly are retried twice. So when you have idempotent non-idempotent APIs, it's you don't really want to retry, and we wanted to change it. It didn't exist at the time. I think last year, end of 2021, start of 2022, there was finally a way to change the policy. And in the mesh config, now you can use the default HTTP retry policy to override it. And it's really strongly recommended, because especially if you have non-idempotent endpoints, you should not retry on conditions that are not clear with the RFC specification. Then the next adoption challenge is about proxy performance and capacity. So you are adding sidecars everywhere. So for each pod, you will have one sidecar. So each sidecar means compute resources, mean added latency. And the Istio community has been always raising reference values. I'm saying I'm giving the 1.9. It starts getting very old, I think, but it didn't change so much over the times. There are some optimization, of course, but basically there are some latency that is increasing without telemetry, like 2.65 milliseconds at P90, and compute resources. Your mileage may vary because, as I said, with the sidecar CRD, if you don't have the sidecar CRD, it can be crazy high. You have 0 RPS, but you use 1 CPU. It's crazy. It sounds crazy, but that's the reality. So it will also use a lot of compute resources, especially if you don't control the configuration propagation. And we need to think what we want when we implement Istio, because it's a technology. Service mesh is a pattern, but you need it. If you don't need it, you should not look at it. So you need to think what is the added value to the business. It can be agility, observability, security, and you also want a reliable performance because you want to minimize the performance loss from the data path overhead, and also keep reliable systems that you can troubleshoot. You cannot troubleshoot your system. Basically, it's worth almost nothing because the first time it will break, no one is able to solve it. So if you are in that situation, you may have very long outage that will have a potentially tremendous impact to your business. And also you need to think of cost, because we need a reasonable cost. Like we cannot use unlimited compute, unlimited money. So we really need to understand what are the appropriate resources for the sidecar. And that's all about the trade-off, basically. How acceptable is the performance loss for the added value, and how much you should pay for the value added to the business. And to answer those questions, we need to take a look at what are our use cases. So in fact, we have many different workloads, even in the same product, like latency sensitive workloads, or like long-lived batches, web intensive. And you don't have any way to say, okay, this is a common way to apply a guideline to all those different categories. And you need to involve each owner and to brainstorm, understanding how the application is behaving and what they will expect in terms of traffic. And considering that, we need to think of the use cases that will give us an answer. And the cost part is basically about the compute cost of Istio. When we have n pods in a cluster, we will have the same n sidecars. That is the base for our calculation. So basically, it means that in our case, we try the first case, one size fits all. So you fit the biggest workload. The pros is that it's very easy to set. You take your biggest pod in your cluster. You just set the sidecar so that it fits that biggest pod in terms of traffic. But it means that you have a lot of room and sub-optimization of resources because of that. The second one is to adjust based on the workloads, because if you know exactly your workload is at that much RPS and you require that much CPU or memory, then you can adapt each proxy to have the appropriate value. But on your side, how do you understand that? It's very difficult because you need to load test and adjust values on a per case basis. So you spend a tremendous cost in trying to have those values. So for us and for you too, one size fits all is too costly. We all think about how to optimize our utilization in our cluster. So having crazy amount of compute that is not used is maybe the worst thing that we can do. So we need to think of how to adjust the sidecar size. VPA and HPA, I think there are some improvements in the recent years, but it's still not clear the path to have a very easy to do automatic adjustment of the resources for the proxies, the sidecar proxy. And for us, realistically, the only way is to load test the application and load test the sidecar. But I hope that there will be more tools. More recently, we are going towards a path when we can do that, but it's still not really production ready yet. Then quickly about load testing. That will be almost the last part for this presentation, but we want to understand what is the traffic pattern when we use Istio. So how many RPS do you have without using Istio? And also how many hops do you have per request? For example, you get one request, you respond. You get one request, you send a request to 3 services and you wait the response and you call them back. Are you calling an OTN service on every call because you're good at security, right? You have proper authentication of any request. So all those requests, basically, they will be counted in the Istio sidecar as a request per second. So we see in the next slide that you can see in the different workflows, one request will have from 2 to 5, varied from 2 to 5. And basically it means that in terms of Istio-based RPS, so when you look at your library, your observability in library, you may have like a 10,000 RPS, but in Istio you have twice, like 20,000 RPS. And same thing for 5 requests per request incoming, you have like 5 times, so 50,000 RPS. So there are many people that think, oh yeah, I'm only at 300 RPS, my pod should be fine. But actually, sometimes it's, you have 3,000 RPS because you call like 10 services. We have a lot of microservices, so we call a lot of microservices, and we have 3,000 RPS. So we need to reason around the 3,000, and the issue is this value doesn't exist. No one is knowing, okay, I'm calling 10 services, I have 300 RPS. What is the effective throughput for my proxy? And we need to adjust the resources based on that. That's also something that the HPA also, they don't know at all. So that's where we need also to revolve on having accurate metrics if we want to make any decisions around that. So the final point about the performance is envoy concurrency setting. That is also very important. By default, envoy and my Istio is configuring envoy to have 2 workers. So one worker is basically 1 CPU based. So if you have more than 1 CPU on an application, you will need more than 1 worker to properly use the whole CPU. And the best way is to have at least 1 worker per vCPU. So if you have even 1,500 millicores, you should have 2 workers instead of 1, because you will waste the remaining 500 not being able to process the traffic. You also need to load test the workload at different level of concurrency and resources. Just scaling out the resource will not have if you don't change the concurrency. Accounting for the RPS per pod and be aware of the HPA is very important as well. So the capacity will really change a lot depending on both CPU and concurrency. Yes, and no, actually the last section was about abstracting Istio, because it is a very important aspect. That's something we invest a lot, and basically making an adoption easy is really about abstracting, because when you don't abstract Istio, basically what you do is you expose a whole new layer of YAMLs. And if you are already having a platform on Kubernetes, you have a lot of YAMLs, developers have a crazy amount of YAMLs, maybe they hate YAMLs really, they don't want to care about that. So it's not really something you want to add, because Istio configurations are very, very verbose as well, many things to learn, understand, many mistakes. So that's not something you want to expose. So the final goal is we always need to keep in mind that we want to improve our users' productivity. Like your platform, your main goal is that you have the business to run, but also you need to make it in a productive way and gradually increase the productivity of your developers so that they can increase the business value quicker. So when you think that, when you make decisions as a platformer, you always need to have this in mind. Do my change is beneficial to the productivity of my users, or is it not? And why is it not? Is it not for the good reasons? Let's say security, this kind of thing. You definitely need something. But in the case of Istio, there is no clear aspect of saying, no, we should reduce our users' productivity. We should think of how to make it very simple to configure and use by our developers. Then, in the same way as we build libraries or interfaces to improve productivity, we need to have the proper abstraction for Istio, such as automating the onboarding, making a feature fully automated and managed. And it will help a lot about the user experience for developing services and the maintainability of Istio for operators. We always need to think again on the platform side operation. Can we sustain the operation? Will it be a big operational debt for us to introduce Istio in an uncontrolled way? So it's very important. And in our case, how we do that is we are using Terraform to handle the Sidecar CRD policy and a CI/CD pipeline based on Git to apply them. We are also using QLang to template a simple DSL for managing various features. And we have this kind of service mesh interface too, where we start having full Istio onboarding, like automatically configuring all the life cycles, the injection, having a good managed canary release with Spinnaker. We have a new CD tool as well based on Argo that we are working on, but that's the same implementation basically. And we are thinking of many more things. Yep, that's it for this slide. So last part is the takeaways for the second part on adopting Istio. So we saw that headless services are erratic with Istio. We need to use cluster IP services instead. So we need to wisely plan the migration. We should use automation pipelines to label deployments for having traffic shifting. Istio has a risky default policy for non-idempotent APIs. We had to fork it before. Now you can just change the mesh configuration to do it. Having sidecars everywhere is a huge cost, so you need to mitigate it by having proper sizing and testing or the appropriate auto-scaling mechanism. And also the abstraction of Istio features is really the only way to spread the adoption and maximize the added value. Yep, that's it for today. If you're interested in helping us to go to the next step, we are really happy to have you having a chat, or we can have casual meetings, or we have the link of our open position now in this slide, but I guess like everyone in the meetup can also provide you with that. But yeah, it would be really great to hear more about you. Thank you so much for today. Raju, back to you.
Yeah.
Can you hear?
Rafael, can you hear us?
Yeah.
Yeah. Okay. So my question is, given what you told us, it would be a very, very sadistic person who would actually be implementing Istio in their development environment. And I'm seriously not sure why you would do it. Because if you're just getting a 5x request per second stuff after doing so much pain, it might actually be cheaper and better for developer sanity to actually just increase the amount of pods and increase the amount of resources than jump through so many hoops to do that. That was what my whole takeaway from this whole work is. You did so much work to do it and you have so many issues that are there. To my mind, it doesn't really make sense to implement it.
Yeah, thank you very much. I think that's a great point, actually. That's true that when you see how many challenges you have with implementing such a solution, you really think sometimes, or is it really worth it or not? That's definitely something we considered several times in the adoption. Is it really worth to have it or going forward with it? But then we also thought, okay, what are the reasons that we want it? Because when you want a service mesh, basically, it means that you already have so many services. I say we have more than 300 services, right? So just one example is, how do you manage the TLS certificate management with 300 services? How will you make the certificate propagation, rotation seamlessly? It's not easy at all. Like, if the requirement for you is to have, and you should have, like, proper TLS between your services so that no one can eavesdrop your communications, and this kind of thing that will be a requirement. And especially you have this kind of PCI DSS requirement or higher compliance requirements, and how do you make those implementations? And there are many reasons that in the end we think, okay, my service mesh is hard, but basically it's one of the only way to really have a common capability for all applications. And the TLS, the mutual TLS, is only one thing, but most of the infrastructure building blocks that you're providing for your services, they need to be consistent, because you are one platform, right? If you have 300 services, dozens of teams you need to care about, you can never have the time of saying, okay, one team needs that thing, that other team needs that thing, and you cannot spend the time on every team, right? The only way is to have one central way of providing most of the capabilities, the building blocks of your platform. And the service mesh pattern, I'm not saying Istio itself, but the service mesh pattern is still a really great way of providing most, if not all, of the network related capabilities in a central way. So it's a huge benefit if you get it right. And we are reaping the benefits over time. We also have, I think, Raju shared in blog posts about our dynamic service routing system, but it basically is the same thing. How do you manage headers across your entire infrastructure and having an intelligent way of specifying a version of service that you want to test with? And again, if you don't have the consistency, then only some services will be able to be tested. And it means if you go with your own way, you need to think of all those dimensions. So in that aspect, my Istio itself is still saving a lot of time on not having to do it by ourselves. Because most of the people, what they did in the past is, and I have so many stories of medium to big companies that said, okay, we have our own envoy-based control plane. We do our own way, but then they say, oh my God, we cannot keep up with the engineering power behind Istio, and we are so much behind. So in the end, they say, okay, how can we migrate to Istio to reap those benefits? So it's a lot of trade-offs, and there is no universal answer to that. It's really up to you. How much can you invest in that? How much do you expect to get from that? Do you have, in the first place, so many microservices that you need a service mesh? That's maybe not the case, right? So for us, it fits our case. Definitely not for everyone.
So, hey there, can you hear me?
Yeah.
So Istio and Kuma, I was looking at the GitHub directory and I found that Istio has way like, good popularity compared to Kuma. So because you have been already building a platform around Istio, how do you see Kuma? Because Kuma has a very good like atmosphere and very good community with open source. So how do you see this? And like, considering that you deal with B2C traffic, where traffic is unpredictable for offers and products, which one do you think is more mature to use for something like this, something like your platform?
Okay, thank you very much for the question. So, Kuma, so to be honest, like, it's been a while. I think when we investigated with Istio, Kuma was almost like starting only. It was very, very experimental. To be honest, I don't know the latest state of how Kuma is nice now. Definitely, I think like for us, it's hard for changing a solution now. We are pretty much far into the sunk cost fallacy now with Istio, and there will not be much benefit maybe. The one other thing is like Kuma, and maybe there are two big components, in my service mesh. They also kind of closely coupled with API gateway, because many solutions now they call them a service mesh, but then have API gateway centric or really more east-west service mesh centric. And from my knowledge, I know that my Kong was and is still. Actually, I used Kong like almost 7 years ago, I think, in a startup when I was in France, and that worked well, but it was very ingress centric, API gateway centric. So I'm not really sure how much they managed to have the integration with the east-west traffic. For Istio, Istio is being able to do both, but it's limited, I think, in the abstraction. If Kuma is similar to Ambassador and more focused on having the appropriate abstraction on the north-south ingress layer to have a real kind of API gateway, then that's probably way easier to go with those solutions. But it's very, I'd say it depends also what you want to do with both solutions.
Hi, there's another question regarding your slide which was talking about proxy performance and capacity. You are telling that so sidebar performance latency was 2.65 milliseconds at P90. So my question would be, how do you compare with Kubernetes performance? Because another part of the question is, you're told with the no telemetrics. If you could tell us with telemetrics how much it would be, and without telemetrics, what you have mentioned. So 2 questions can you answer?
Oh, thank you. So for the first question, I didn't really get it clearly. Is it about Kubernetes and the performance?
And with your performance, right? Sidebar performance, what you have told. It's 2.65 milliseconds.
Yeah.
So how do you compare with the Kubernetes? That's my question.
Yeah, I think, is it like because we are using Kubernetes, so already we have those latencies. Like if one application talks to another application, then we already have that latency. Let's say between service A and service B, the API call takes like, let's say 20 milliseconds, 30 milliseconds. So that's already there. So are you saying like
no, I wanted to know the comparison metrics, that's all.
Okay, so the comparison is whatever latency was there before, Istio will add up like 3 to 6 milliseconds on top of it. That's it. So that's the only difference.
Okay. And also, I'm not aware of this telemetrics. Could you please highlight?
Yeah, so Istio does provide, I mean, one of the feature, like, because I mean, a lot of observability feature, like you can get the tracing, telemetry, and metrics out of Istio. But in our case, we already use Datadog for that. So for all the like distributed tracing, logging, and everything. So we haven't explored much on Kubernetes Istio's observability features. But talking, I mean, if we relate that to the latency, there won't be any much difference. Yeah, but you need to change your applications and also the control plane to install those extra additional kind of like, because currently we only use Istio D, which was pilot, but Istio, if you want to use telemetry also, then we need to use Agar and Zipkin, all those we need to install, and we need to have the Prometheus also, but we don't have, I mean, we are in process because the Datadogs observability on with Istio, the integration of Datadog and Istio is not that good. So we are in process to like, okay, if it's not good, maybe try Prometheus. So because Prometheus natively have good integration with Istio. By default, like when you install Istio for all the observability related thing, Prometheus is the one. Yeah.
Yeah. So no, that's really, really nice because nice question, because basically what is the latency in an application? It's how long do you keep a request in any component of the chain, right? So when you add Istio, for example, Kubernetes doesn't matter so much compared to your proxy, because Kubernetes, depending on where you have your cluster, you will use the underlying network parameters or the data path to have your traffic. But what happens when you have something like Istio is you have a proxy in the middle, right? Or proxy in two places. So instead of having a direct communication, let's say from one pod to another, you have two proxies in addition. So how long that request stays in the proxy and how long the request stays in the proxy, it's same as any application. How much logic are you running on that request before letting it go to the destination? And so naturally, the more logic you add, the slower it will be, right? Because if you trace, if you terminate something, you try to find some value of something in the request, you try to make a decision on that, and try to add some metadata, all those operations, they are having cost. And the biggest cost is really depend on the case, but moving data, heavy data is quite expensive. And telemetry is also, you need to block getting stats, sending, depending on how the implementation of telemetry, it will maybe cost a lot for you to have it. And so that's where I'm not an advocate of having full telemetry within Istio too, because it may be not very performant, and they have better tools that you likely have initially if you are using an APM tool, Datadog. We said about Datadog, but it is a part of, you don't need to have everything in the service mesh as well. Of course, if you don't, then, and you're ready with the cost, the latency cost, it makes it cheaper for you to have it in the service mesh rather than buying another solution or creating another solution, then it may make sense. If you're not latency sensitive, you have things that are not responsive, you can have a budget, let's say, I don't know, 100 milliseconds. And so if the sidecar with telemetry adds like 20 milliseconds, you're still under budget. So there are so many dimensions to look at it, but it really depends on what you need for your application. And I'm just sharing the official documentation of Istio 1.16, but basically they give always the benchmarking on the different kind of configuration with their test suite. And you can see at P90 that depending on the version, so stats that is taking, I don't remember the stats, maybe it's the one having the telemetry, but basically it's not varying so much. I think especially because recently WASM is used a lot and optimized the null VM, the lighter ways of doing WASM or integrating the logic that reduce the latency. But it's not a crazy increase actually. But it does again depend on what you will do in your proxy. You can do so many things. So if you do things in a weird way, you will have a crazy bad latency. If you do very few things very simply, you will be near the baseline.
Thank you, Rafal. So we have two more questions on the online. Meetup. So first is like, how does the Istio proxy integrate with existing service discovery and API management tools?
How does Istio integrate with existing service discovery?
Yeah.
Yeah, so that's a very good question too. I would say it really depends on what is the tool. Because Istio, basically it use open telemetry to get the tracing, the statistics. You can use Prometheus for that. For service discovery, it's pretty close because it still makes its own registry of service discovery. So it will take all the Kubernetes services and populate its own registry based on that. So let's say integration with Kubernetes service discovery is native, but anything outside that, it's really depends on what you're doing, because the simplest way is to, if you have a service discovery tool, is to make it compliant with the Kubernetes. If it updates Kubernetes, then it will update this registry appropriately. But yeah, if you have an already existing service discovery, chances are that you're using XDS protocol everywhere, and then you can just plug the XDS APIs in Istio, because Istio is based on XDS too. So if you add things externally from your XDS source, then you're able also to augment Istio. So I would say that anything that is not XDS based is not really, will not work with Istio unless you feed that service discovery into Kubernetes, and Kubernetes change the services, the endpoint slice appropriately, so that it's kind of indirect integration. But it would be maybe easier to have the direct XDS integration.
Thank you. And another question is, can you discuss any upcoming initiatives or plans related to Istio or service mesh adoption at Mercari, Japan?
Yeah, there are so many actually, you know. Let's say there is a wave of potential to tap in with that. I would say that recently, the dynamic service routing is very, very, very nice, because we had a very hard time in testing our microservices when we moved from monolith, and because there are many ways of declaring what is a test, what do you want to try, and basically what we are looking at is having this standardization. Each proxy, each application in our infrastructure is having the same baseline. So whenever we make a change or an improvement, it benefits to all services. We don't say, okay, just that service, we have this new feature. So the goal for us is to make sure that we have the testing ready for everyone, so that we read those headers that are in the request, and we have like 5 services in our call. For each service, we specify which version we want to make this kind of test request. And with that, we can have a clear separation of testing from, let's say, more stable, let's say, pre-production or staging services. This kind of isolation and proper control that we want to keep going forward. Then lots of optimization as well. The locality-based load balancing. So, you know, when you're in a cloud provider, you have a cluster across several zones in the same region. But when you do the interzone traffic, it costs you. And if you have a lot of services, a lot of traffic, it will cost you a lot just for that interzonal. So having a very native way, my Kubernetes can do it to some extent, relying on some of its network primitives to have the traffic within a zone, if possible. But with a proxy, it's great because we can 100% control it. We can make sure, okay, the destination are in zone A. So we only send to zone A. We almost never send from zone A to zone B. This is another part that we are looking at into cost saving. There are other features. We are looking more on the north-south too, how to delegate with gateway API the management of ingresses. So, you know, you have path, you have many domains in your company. So how do you handle those domains, those services in a swift way, smooth way, so that you don't have this kind of gateway maintainer that every time you have to call them, okay, yeah, I have my service, I want to change something for my service, so please change the gateway for that. This kind of delegation mechanism that we really want to make happen so that teams can be really kind of autonomous, but with the controlled delegation. So those are other parts that we want to do. And the next thing is that so you know, Envoy, well, Istio, without Envoy would not be Istio at all. And my Envoy is so powerful, and Istio is still tapping a small part of the Envoy potential. So Envoy can have a lot of filtering. You can change the filters, make a lot of different logic for different protocols. And our goal is to have providing a catalog of features that you can very easily chain for your use case. So, and because everything has the same baseline, the same standard, then we can have this kind of building block catalog. When you say, okay, I want some, I don't know, protobuf awareness, like doing something with protobuf, getting the field into that, doing some kind of OZ, handling a lot of different OZ patterns, retries, circuit breaking across the entire company. These kind of things that are very hard to do on a single service basis, we can really have the flexibility in defining the different logic according to the use case. That's very broad vision. But overall, like more than that is like, as a platform, we really want to have this easy to use, smart default, and it means that you need an easy way to provide the features. And giving a modular approach, having this kind of module catalog, being able to quickly, easily use that, it's a great state for a platform to be at. And personally, on network side, it's very important for us. And we are striving to have this approach on all layers, basically, of our infrastructure, be it at service mesh, be it at API gateway, be it at kernel level or eBPF, like really having this flexibility of adjusting what is needed and also having the strict minimum for each isolated from each tenant is very important for us. So this helps. We have a lot around that too.
Thank you. Thank you, Rafael, for great presentation and clarifying the thoughts.
Thank you very much for the
yeah,
questions. Thank you.
Yeah. So yeah, I think we have 2 more presentations, so we can take a break because it's been a while. And yeah, so we will be taking break. So Rafael, if you want to be there, you can, or maybe when you can free to leave. So, but we will be back in the 15 minutes. Yeah.
So I'm now sharing my screen. Breaking time now. We'll start soon.
Yeah.
There are snacks arranged. You can just follow me. हो गया आगे भी हो आगे भी हो पता नहीं अभी टी मीटिंग गया तुम लोगों ने सेटअप किया yeah this comes with WeWork.
I think this comes with WeWork. In the office just next.
This is all a setup. Yes, regular setup.
नहीं आज ही
Rent पे है. कितना रुपए?
नहीं उधर से कुछ ठीक है बाजू में लेके तो ग्राउंड में लेकिन उधर से अभी बाहर में कुछ नहीं
Actually, the mics are not Bluetooth connected. So when you speak in this mic, it's connected to the only speaker, not to the laptop. That's the issue.
So you are picking and holding the.
Yeah, exactly.
What is the other way to do it?
The mics are like it need to be Bluetooth mic.
No, usually they can do it, but that output
But when you're speaking from there, laptop is good.
This mic is connected to.
Yeah.
That console. Right?
So this
Here the
connection,
mixing console.
this connection and this speaker connection.
laptop
But I'm saying that should have been the one, na?
Yeah.
Understand? From that console mixer, it should have gone to the laptop also.
Yeah. So that's not.
Yeah. The laptop की input output. Actually, laptop की input output should go to that console.
Laptop में जैसे speaker का output जा रहा है, but laptop cannot take the mic. ये पुराने
There has to be some other way. We're missing out because ऐसा नहीं हो सकता कि well, we are missing one thing. And Bluetooth is not the solution. It's not the only solution.
It's one solution, but usually, I mean, the system पुराना है, वो भी है. क्योंकि laptop में option आ ही नहीं है ना, input का, microphone का.
If you plug in something, then you should be able to plug that mic in. Oscillating. Aux है.
Laptop.
Laptop में aux है.
Laptop में ये speakers नहीं है.
Hello. How do you?
See, सबसे बड़ी problem है.
How do you speak? Huh? How do you speak like speaker? Not working. Speaker is not working. Settings. Yeah. Mic and then speaker. What is happening? Oh,
There is one thing which is missing here. You should have at a 3.5 mm.
yeah.
Or 3.5 mm, there is a white
External
port which connects.
Can you mute yours?
This is 3.5 mm.
No, sure. Same. Why? Hello. Hello. The back unit is this. Hello. You need to unshare. Oh, sorry. Somebody's sharing.
Kayo-san needs to unshare.
She's asking when should we start?
We can start now. I think in 2 minutes so we can call other people and then start it. So I'll call other people.
उसका मतलब लाइट लॉक में मिलता रहता है। हाँ सीरियस क्वेश्चन पूछोगे, सीरियस नहीं रहता है, सब उसमें डेटा रहता है। नहीं तो जो लेकिन वो डेटा रहता है। क्या कर सकते हैं? But you don't know the business requirement, the business requirement, that's why they are not. They are working on other business, but business requirement है कि नहीं वो तुम तब but you did work on that. तब भी जाता है नहीं जाएगा ना कैसे ना as long as I put the subscription नहीं है तो सीरियस एक्सप्लोर कर डेटा सब्सक्राइब नहीं करता और जो एग्रीमेंट है उसमें डिटेल एग्रीमेंट मेरा तो भरोसा नहीं सर बिजनेस से मुझे जो काम तो नहीं वो मैं ये डेटा जाता है तो मैंने देखा था डेटा बहुत सारे डेटा वो garanti नहीं जो हमारे उसको no I just sitting there just आशीर्वाद दिया जाता
Did she start?
Yeah, streaming. Okay, I will. Yeah. So I will start as.
Check the YouTube. This is not active. I think your screen is connected. So this is not representing there.
Yeah.
Right? Can you check now?
Starting. Yeah.
Starting?
Oh, we cannot see your screen. Are you sharing the screen?
Yes. I think YouTube is linked to yours. Maybe.
No. It's iOS actually.
I think it's slow. Wait,
Okay.
it's slow, I guess.
Okay.
So now the in-person meet will actually start. Sorry for the sorry. Yeah, I'll start. So hello everyone. This is Ankit, and I actually started to host this platform in community in Bangalore. There was a great community for the platform, and there are a lot of company actually human tech started, but a lot of companies sponsoring for hosting it. And earlier there are a lot of online events was happening, but this is the first time I tried to communicate and then host a online like in-person meetup. So I work at about me. I work at Weave HQ. It's a Utah-based company, like Utah in, near to Salt Lake City, US, and they basically build software applications for dentist, veterinary, opto, and small businesses tools. So I work from India team, and I'm in a developer experience team. So mostly I'll talk about the tech stack we follow, the deployment pipeline follow. It's very new culture, unlike this old EC2 and stuff. We also use Kubernetes. So
Just to understand that those are multi-tenant applications.
those
The
are,
one which you're working, multi-tenant applications.
yes. So what exactly is platform using? So earlier we in history we used to call ops team, DevOps team, and then after AWS started into 2006, they started with Google started with SRE team. So in this last 5 years, there's new trends come up with platform engineering actually. So mostly all of the companies started leveraging their cloud platform and how efficiently their engineers can solve their problem rather than focusing their actual logic, or rather than focusing on their ops logic, they need to just focus on their product side or backend side. So a lot of organizations started to struggle with say manual process. If a developer has to build a new microservice, they have to do a lot of setup stuff and other stuff, and they spend a lot of time to doing that, and that is actually costing the developers time. They're actually not increasing the developer time to reach to the feature, to build the feature. And now the platform they design, the platform engineering, they design to maintain and ensure the software development process to build a efficient and stable and consistent, so that your organization developers just to focus on their product feature, and then just create a application, and they just need to learn that. So in the same at Weave, we have our own tools which we develop, and the other other developers, they just need to learn our tools and then start building the feature. So the first tool is BART. BART is internal CLI tool which helps the engineers to automate and simplify tasks they developers do each day. So what kind of features they do each day? The first is deploying services. So there are a lot of process, there are a lot of things people use to deploy a process. The other is creating a new fresh service. Like there's boilerplate code, getting API token to log in your microservice, roll back your deployment. If you have some issue, you need to roll back, how fast you can roll back to your system. Port forwarding service, you want to connect to some microservice and you have some port open there and you want to port forward that. Documentation search, every developer has to read about the system and they want to do some search over the documentation. Managing secrets, setting up local environmental configuration. Sometimes you cannot able to set up your local environment because all of systems are in production. You want to run in a local, right? UI, tailing service log. We use GCP for our cloud, and we tail logs from there. And there's a lot command, but there's some feature we built using and we call as a BART. And basically BART is built using Golang and Cobra. Cobra is a famous Golang package which helps you to create a CLI package.
When you say tailing service log, it is basically multiple layer of service, one service calling
another
microservice and doing performance.
You just tailing service log, you just mean to pull the logs from the GCP using the CLI.
Get the log and run.
Yeah. So how does it look like? I don't want to go in, so I have attached some screenshot. This is my testing microservice, and we have platform demo. We name as a platform demo. So the first command which people engineers do use then is BART build. So we are a completely Golang based company, and using BART build actually show your last 5 builds, and it's the build is GitHub deployments build. So you can whatever the Golang binary generated and then actually stored in somewhere in GitHub deployment, it can show. No, it's not. It's very similar to what Humanitech is doing. They are building a SaaS platform, but this tool is for my company to.
Only for internal use?
Yes.
It's not open source?
No.
Then
I don't have any plans to. I don't know about the.
See, just let me. These are things that every company has been doing these things at one point or the other. Everybody has their own build scripts, make files, all that shit that happened in a long ago. We have all been building it. What you have been doing, what you have done is a nice thing to do. It is abstracting away a lot of the common stuff into a tool that people can do, possibly get some sort of configuration or adapt.
Agreed.
So if you open source the tool, it would be good because then you would be able to. These are the things that we need to do, and the GUI or the React use that is only a limited function. The real feature comes in the command line, the Ruby command.
I'm not sure about making this as open source as of now, as the company goes, but like using the new tech stack, using the new terminology in the market, and we are. I feel that we are ahead in this time, and it's very good to share our learning and knowledge to the community.
basically, you are setting the features that if someone wants to build their own product.
But the backend I will use parallel SSH and all those sort of things. Then all these tools people are actually built using Bash. Scripted together using Bash, scripted together using Python. Largely Bash is hardly ever in the other area. SSH कर लो, ये कर लो, वो कर लो. And do अगर कुछ ज़्यादा fancy आदमी over enters वगैरह लेके कर लेगा. I mean, I'm just saying that. So, but this is good because Golang is interesting.
Now moving to this, so when you do a BART build, it shows you last 5 builds, and then it has some SSH tag as well, and there's URL where your Git URL for all these builds, and all you need to do a BART deploy where you can just I use a latest flag. So whatever the recent build you created, that you can select your environment to use, and you can right now deploy it to your development and production. So now the next thing, a lot of people earlier used to do like writing Kubernetes manifest and then doing a kubectl apply. They don't need to learn about this. They just need to focus on their feature, and all they need to do just BART deploy, and they push their code, they approve their code, and then they use a BART deploy. So when you do a BART deploy, they also print like a lot of we use the Argo CD, so it print your Argo CD link. We use Grafana, so it prints the Grafana link. So you can right away monitor your deployments, and then you can just go away to the link and then check whether your services is healthy or not. Now coming to the rollback, I say people do rollback a lot, right? So how fast you can do it? So you just need to do a BART rollback, and then you can ask what environment you are doing to rollback, whether it's production or development, and then it will show whatever the last 5 or 10 changes you want to do a rollback, and then you can just do it. And then you can have a Argo CD link where you can check whether your service is healthy or not. Now, the using BART helps our developers a lot. So earlier, developer has to write their Helm chart, Kubernetes YAML, and then they move to the CLI tool. Their productivity increase a lot. The feature developer times doing this was not sufficient, and they started to moving this to BART, and they can actually, some people don't want to learn ops stuff, right? And some people just wanted to do data stuff, and then they just wanted to build features around the company, or their product manager have some new feature coming to their table. So they don't need to, and they actually like this. okay, I don't want to write a Kubernetes YAML, I just want to do this. Now, WAML. WAML is like a small manifest which just we create to just match to tease the developer. You don't need to write a complete YAML file. All you need to do, learn some of the field where you can actually define so it's like Weave developers interact with system Kubernetes, Prometheus, alert managers, and you can write in your services .weave.yaml file, and where you can write those fields. So you want to deploy to environment, so you can use a deploy, and then you can mention what environment you want to use, what ports you want to open, and what services you want to do. And if you want to do, write an ingress, then you can also do this. So earlier, what happened was we used to do parser Helm chart a lot, and then we try to create Kubernetes manifest, and the developers used to write. But then we created a set of WAML file, which actually there is just few things you change in Kubernetes YAML file, and if you figure out, this is the point where you don't need to write all of those 2,000, 3,000 lines. You just need to figure out what actually point you can mention. So
so what we are doing is the changes that you want to do, you populate it.
Yes.
And then you possibly merge it with that.
Yeah, that is exactly the.
But I have a question here. This is I think is pertinent to everybody. Why you have YAML? YAML, the challenge I feel with YAML is that white space becomes significant. And I actually do think if any language that makes white space a significant sets people up for.
I think
there was make files. If you see make files, one of the biggest points of make file developer, he himself wrote that the biggest mistake of my life was to actually use the tab as a space separator, because the tab is invisible. YAML maybe it's a space, no space. I mean, I think we should actually prefer JSON over YAML. Seriously. But it will take less space in there.
Yep.
So I mean, frankly speaking, I agree with you, but okay. But if you're going to the smaller application like sensor or some small microprocessor, there are certain areas tomorrow you want to plug and play those in case. But if we are looking at the DevOps side, lots of files, all the data is sort of user needed. Right? It's not that much machine needed. My point is that if you open it as an editor and if you inadvertently forget a space, but your whole file,
editors are in support of all this.
So I'll tell you one thing. I'll tell you one thing. A lot of people having facing to write actually this WAML file as well, and so we decided to build a command just down to indent, clear indent. You just need to do a BART FMT, and that will format your WAML to exact the same thing.
That's the point. Yes, you need all those additional tools to do that. My whole point is that I don't know. I don't like files where yeah, that is a valid use case, but that is a use case which is I mean,
yeah, like different use cases for different scenarios.
See, XML I believe I agree with a lot of people who are those for common. But anything you just have to open those places and you can be sure of the structure, because in YAML the structure finding is also difficult. That's what my feeling is. When I'm read YAML, I'm actually not happy with YAML. My question.
Yeah. To add on that, yeah, we also have similar tool which is called the escape, and it's very similar to JSON. So I agree with your point that because here, let's say we have environment name, then that value, if you just bring one space behind, it's equal to environment. So even your tools cannot find that.
In fact, last year we built a tool around Golang. We use Golang ID, and we use we created a tool plugins which can actually, when you put a colon, which can actually show some suggestion what you can do here. Yeah. So you can do something like this to put developers life easy. So if you can create some Golang plugins or VS Code plugins, that can actually help you to.
But then still you have issue, right? There are, like, let's say you have 70 recommendations, not put 70 recommendations. You can only put 3 to 4.
I mean, my perspective is only that it's prone to error if you're opening it as an editor. That's the whole concern that I have. Because you cannot see where, and that's why I think, again, Python has this problem, and that's a true problem. Python will code 90%. If you forget an intent, you try to achieve, but many of the editors wrote it. But that's the good thing with Golang did is that it at least took the seek of race wala concept and said, okay, we have these separations.
Continue on the same. Earlier, people used to write a lot of YAML file. Now we just pass to 80 to 100 lines of YAML. And some of the major features of this YAML was you can mention your deployments, secret managements, shared configuration, how do you monitoring your alerts, SLOs, HPA, and even feature flag and documentation. So whatever you want to do in your common services, you can use this field, and then you just need to do this. You don't need to be build a new service around the same. So some of the examples, yeah. So we use Vault for maintaining secrets. Yeah, HashiCorp Vault. So here, I don't know, here's not example. So something like how do it work? You do a BART secret command, and then that it will ask what environmental name and value you want to do. You put it there, and that will create a PR for you on GitHub. And in a common repository, we store that, like we send the decrypted encrypted text to the PR, and once that pull request is merged, that will go to the vault and decrypt there. Yeah.
Does this tool require authentication? Because
Yes. It is SSO based. So you need to be like log in with GitHub, or you can you have to pass GitHub token, because we are completely based on GitHub and Git. So you need to be log in with that. Now you can see in the YAML, I mentioned a lot of features. So let's say your services have a HTTP open at 8,000, so you can mention there, and then you can also mention resources. So how much memory the CPU will take, the limits and the scaling, how many replica you want to create. And then if you have some feature flag you want to use in your service, so you can also mention the feature flags. And then again, the last thing is deploy. What deployment configuration you want to do.
I have a question. Do you ever feel like someday it's going to become as big as Kubernetes configuration?
Yes. So
the whole point of doing this was making things easy.
Yes.
But at some point of time, if it becomes so big that okay, I'm going to bring my this control.
So the thing is,
it's going to probably become as big and complicated as the original YAML files were. And I am honestly every day afraid of doing such things, because I have to keep a check. What if I'm building something more complicated?
So when you create an IDP team or DevX team, you have to be very like communicate with your developer. Your customer is your developers, your company developer, and what they want, you have to build you have to build a tool around the same. So even in fact, we also do some research on open source, and we try to implement that in the same thing. So whatever, I will not say we are perfect or something, but whatever the use case of developers are here, and they just need one day to learn the command, and the next day they can do a first deploy. Now, yeah.
This is the previous file was the one that you write, or just the merged one?
This is the other developers write, not the merged one.
Okay. And then to merge it automatically,
we have a common service which we wrote to. The next slide is actually this. Yeah. So I will say it depends on the like product manager, how much they say, like what is your service level objective and then agreement. So you can't say your uptime is almost like a 99.99%. So it depends on you. We just created a platform where when you create a service, you can provide this much SLA we can, or SLO we can give to the customers. So now we has a lot of small customers, and we are as a platform team who does build to the other team, and they have some features. They are whether they are payments team, whether they are some other team called team. They have to give that this is my SLA. So we can just provide a thing where you can mention this is our SLA or SLA. So now this is very few like new term GitOps, and they are like popular in last 2-3 years, where we works actually a company who does build Flux CD. They started doing GitOps thing. So what exactly is GitOps is, you have a common Git repository, and you can do everything around the same. So yeah, so even if you want to deploy, even if you want to create a new service, everything will exist at GitHub. So this is GitOps, and you can deploy faster than like other way. You can also manage your credentials. You can create your live documentation using Markdown files, and all of those you need to just pass the GitHub repo link, and then so. No, GitOps is like a terminology, platform terminology, where you can just build your service around the GitHub or GitLab also. It's like everything will be on the Git thing.
It's as simple as saying domain configuration apps. And if we go back to all those concepts that we have been using for so many years, we have created a new terminology, 61. That's the whole thing that has happened.
So now once you write your YAML, you do a bar deploy, then there is a service which is covered in next is you do write a actual Kubernetes YAML file, and which will sync with Argo CD. So Argo CD is like a GitOps CD platform for which actually managed by CNCF Foundation, and it is you can sync with the Kubernetes. Or so what are the features you can do with Argo CD? So it has a very good GUI and the CLI, and it also supports SSO. And the best thing what I like about Argo CD, the reconciliation between the Git repository to your Kubernetes. So when you push to Git repository, Argo will eventually like it will send a webhook event, and then Argo will pull up this and then sync to the Kubernetes. You don't need to do anything. The developer will open their whenever you deploy the changes, and then the next thing you open your Argo CD page, you will see a new pod coming up there.
So you necessarily don't need to associate with any cloud provider.
No.
Cluster running of the Kubernetes.
So other developers don't need to focus on this, right?
No, I understand that. But quite often when we think about CI/CD pipelines, they're often like API associated with AWS or where you push something to become a method.
Yeah. So once you sync to the Kubernetes, actually the cluster, the Kubernetes will deploy to a cloud, right? So we use GKE for this. So eventually the code will deploy to this Google Cloud.
So yeah, like you can also have like a on-prem, right? On-prem. So in those cases, will it become challenging?
Will it become?
Will it become challenging with that? Because you are not using a cloud provider, you are rather using a normal Kubernetes cluster.
I don't think, because whatever the changes will we merge to this, and then Argo CD will actually sync with this Kubernetes. We also have a SRE team who does actually monitor and check the uptime of the Kubernetes. So to all those Kubernetes things, the SRE team actually see like whether your services, they actually monitor the Grafana dashboard, and they actually monitor alerts as well on call. So you can eventually see whatever your Kubernetes services having some issues and all.
So the simple question is like, Argo CD, will it be dependent on the cloud environment?
No. So it will eventually you need Argo CD installation, right? So once you did do a Argo CD installation, you will just receive a webhook and then deploy to Kubernetes. This
Argo CD can be installed locally?
Sorry?
Argo CD can be installed locally?
Yes. So how does this flow actually get off with Argo CD? So when a developer makes change to any application, it just pushes to a new version of Kubernetes resource to a Git repo, and then your GitHub action, we use GitHub action, your GitHub action will be triggered, and that can create a new container image, and which can also store to GCR to maintain your metadata. And then whenever a developer issues a pull request changing some manifest which were created, either do it manually or automatically. So once you your pull request is merged and reviewed, and then it will once you merge, then your .github.workflow.yaml file will actually trigger. And now we use Go, so we create a Golang binary on this, and the YAML. So let's see, yeah, here. So you can see here in the diagram. So YAML have a two fields: auto deploy, and then the other way you can use it, or bar deploy. When you do a auto deploy, so once your pull request will merge, it will eventually go to the GitHub deployments, and then GitHub deployment will actually create a webhook event, and then now this service, our microservice come, who does actually do 4 features, like as he said, you actually took those points and then merge those. So it's actually do merging. So first thing is we have a lot of set of default based YAMLs. So once you have a lot of set of default based, so you know, like whether how many services you will create, there's some default value will be seen. So the first thing will be, okay, do a blob match and then merge those YAML file to create a new YAML file. Okay, and then once
I have a question here. This may be interesting from the deployment. If my default is say replicas is 2, and my new one says replicas is 1, is there any flagging or anything that happens at that point before you really push it out, saying that right, you are making a mistake, you are reducing the number of replicas, are you sure you want to do it? Otherwise, you might need for some. I mean, I'm talking about, I don't want to replica, I have to get it. Or if I expand it to, let's say, for production cluster, I say, I want to be, when I increase the size of the RAM to something and all, then any sort of gatekeeping or something in there will say that either you are increasing it the resources too much, which basically increase costs. So I mean some sort of oversight system that it just doesn't go and merge it. Or so, it doesn't happen at the point even before you do the pushing. So whatever you declared in, you can see here there is a scaling and replica. So whatever you put there, that will go to like the merging part. And you can also set a maximum replicas here, so you will not scale from that point. And you can also create some Prometheus metrics which actually monitor those, and you can view in your Grafana dashboard whatever the yeah.
No, the question is, today we'll deploy this, tomorrow again I need to deploy with some parameters to change. So it can be CPU or it can be
yes.
So for that tweaking, we need to go redeploy, or is it to I can do minor changes and
yeah, you can just do a minor changes, whatever, if you want to increase your memory.
Does it need to auto deploy or does it need to redeploy?
There's 2 points. If you don't want to auto deploy will work only once your your feature branch will merge to the main deployment branch, right? That will trigger auto deploy. Or the other way, you could do a manual deploy, your branch deploy. So you don't do a auto deploy in your branch. You have to use the command for that.
So
And
you have to do
yeah. And
this point was more of intelligence. Is it intelligence enough? There are 2 replicas already sitting in your cluster already, and you are putting making a choice that I will go with one now, and which eventually brings down your cluster capacity. Is there any gatekeeper which you recently checked what is there in the cluster and what are pumping, like passing through the API?
As a point of SRE, I'm not like a much SRE or expert or Kubernetes expert, but they do some kind of preemptable nodes to use this maintain pods, like how much they are having capacity and then downscale for this. So they are having some also users, but like as a part of the DevX team, we do a lot of stuff to help the basic stuff to create for the other teams and then how to use it.
Because see, there are multiple angles that one may need to look at, especially when it comes to production, production. And you need to be sure that you are not inadvertently reducing capacity or you are not too much overreaching your thing, which is essentially the budgeting. So One is you have a human being who checks this stuff and says, these are the changes that have happened, a diff sort of a thing, and it's all, right? That happens pre-deployment. But for that to happen pre-deployment, what would we really need is that whatever changes you have proposed gets somehow merged with it. And so that at the merging level, either there should be some sort of a thing that says that these are sensitive areas where you should not actually be touching if it's related, then you need to have somebody, I don't know how it will be triggered, but somebody triggering a code review session or something.
It's
And
what
this
has
needs-
memory.
Yeah.
It doesn't save anywhere, like.
Yeah, so I mean, that's.
Also, do you have tracking, like what is the person
Tell-
how the deployment happens?
Yes.
No, exactly,
Yes.
see, this is the
Yeah.
point.
Deployment
If here I put it as fraud cluster, instead of debt cluster, or I put this as replicas one, then some put the replicas one here, wait for replicas two here. That's the exact point actually. That means they were basically creating an issue which result in a failure. So somebody should be able to tackle that sort of thing. Yes, sensitive things, you cannot reduce the number of replicas, you cannot over increase the number of machines in the cluster, you cannot increase the memory or the CPUs related for that. So I mean, somebody has to bound it, somebody should pass on, especially if it's production, you can have a plan that says that if it's production, then needs to go to an SRE manager, somebody who will actually sign it off before.
I think, yeah, our SRE term mostly handle those things only, like basically measuring the uptime of the Kubernetes
No, I'm
cluster.
not talking about that. That's not what I'm trying to say. Before you do a dev पे deploy किया कोई problem नहीं है, वो तो portal और काफे का कोई problem नहीं। जब production पे deploy कर रहे हो, तो you need to have somebody within your pipeline stuff, at the CI/CD pipeline, right? Who can say that these are sensitive, this deployment is touching these sensitive areas, and you can define that as spacious capacity and all, which says that, okay, sorry, you're doing this, I cannot allow you to automatically deploy it. You need to go through a gatekeeping thing, trigger it something, and you talk to, and I need a sign off from you. That sort of a thing is what I'm trying to say. Within the pipeline, that can happen in the pipeline.
So does your cluster have any kind of use admission webhooks?
We use GitHub webhooks.
GitHub is something in the CI/CD. So let's say
Deployment happens on the Git. Because mainly base is Git, over that you are making a UI kind of feature, what we do other. We're doing here as a platform to build and to do that. But still, my question is, when we may require, let's say, custom parameters. Is it possible like that?
Yeah, you can still use your kubectl command. You can still use it.
So
But for the
if I get the kubectl access, then I can deploy anything, or is there any kind of safeguarding layer kind of between the kubectl apply and the actual creation of the resources?
I think I don't know about the like the layer you mentioned, the network layer.
There
Actually,
must be some.
there is
So I
some
think,
layer.
Like answering your question, so even though let's say we mess up with these all environments, at some point that safeguarding layer will take care of it, and actually these deployments will fail.
So
Yeah, so it can go be
the first thing, there is a lot of checks we created on the GitHub pull request as well. So we have around 10 to 12 checks on GitHub pull request. So let's say you have a testing check. Let's say you have a diffs check, whether your diffs is created is valid or not. So there is multiple checks whenever you create a pull request, and this checks will like spun up. So you can see what your checks are failing, and you can just go to the GitHub Actions, check the which check is failed, and then work on that same, and then get an approval, and then continue. So yeah, after like a merging, this other thing is yeah. So like default value, once you merge that, your default value will set to the WAML, and then you actually also validate in the common microservice. So whether once you create those manifest generated is actually valid or not. You can't push to Kubernetes some wrong values, right? So you have to check the validation of those values, and then once those Kubernetes YAML file manifest generated, it will store to our common template common repo where all those YAML file will be stored, and it has also like 5 history. So if you want to do a rollback, you can just move to the previous YAML generated YAML, and then Argo will sync up with this repo, and then Argo will sync to the Kubernetes. Now this is how Argo looks like. So you can see whether once you're able to create a new pod, this will be a new pod will be created. So yeah. Now the thing is a document. Coming to this, this other feature we also support in deployments is a formal deployment. So even if some team want to like do a formal deployment, they just want to do like whether my thing is working live in production, so they or dev, so they can do a formal deployment which you can kill anytime. So yeah, and the last thing is about documentation. Come again?
Formal deployment, right?
Yeah, formal deployment.
Creating a new production like environment and then trying to run and see if it's working.
I wouldn't say the criteria is like just go to the production and deploy.
Not really production like new environment, which is very.
Yes, which is very so a formal deployment almost similar thing. It will provide you a production based environment and you can test it on the same. This is like very new thing we implemented last year is documentation. So we don't want to, we were using some startup group on the base, but how do you cut the cost for the engineers to build a tool around the documentation? So as we are GitOps based, so you just need to be write a lot of markdown files, and then this documentation will actually render all your markdown files, and then so we use a Hugo open source library, and Hugo will actually render all of those markdown files, and then you can also create a page around the same. So now coming to this, do you if you want to write a documentation as a developer, then they just need to do a bar docs, right? And that will create a default GitHub actions for you, and that will read your markdown files. So whenever you create a pull request and you have some changes in your markdown, so a GitHub actions will actually create a temporary docs for you to see how does your documentation look like. And then you can also validate, okay, my documentation is good, because most of the time people do not see the text, but when you provide a GUI, they feel good, like, okay. And then you can also add some architecture diagram using Mermaid tool, which actually you can just write the sequence flow diagram using Mermaid, and you can render that. Okay, so it is very helpful to write your documentation in the ways of the code you are writing.
This is just like Swagger.
Yeah. You, as you raised this Swagger point, I didn't mention a tool we are using. We are completely based on gRPC gateway, and we have a common microservice repository where all you just need to do a push your proto files on that repo, and then proto files will create new, like they will auto generate your Go code, and they will also generate your Open API or Swagger docs for you. So that can actually help the front-end developers to go to the API directly using that tool.
Write down users need to verify the thing that, because now you're giving all the inputs, right? So
yeah. So while how does this tool help the developers to remove the cost, like the developers cost, like this average developer time reduced to 4.6 seconds, and then Argo, whatever the Argo, like how does fast Argo pick up those manifest, generated manifest is like almost 19.4 seconds, and the average developer wait time was 24.03 seconds. So coming from that phase to building an IDP team actually helps your your organization to increase your developers productivity. So
how much is the reduction from original deployment
I think this is our blog, and you can take a like photo of this. But at the time of this, once we're doing it, but I don't have the data, but it actually helps more than, I guess, 70 to 90% to reduce the time.
But the development time is so small that, like, it makes sense when your development time is multiplying by maybe millions of.
No, you said the current account time.
Yeah, this is the current data.
It's not the not for earlier. So earlier would be anything. So that's
Earlier it might be like for 5 months, 5 months.
If you are fast enough to write your Kubernetes manifest and then do this one point is very considered, like you are new to a team and then you have said, your manager said to go learn Kubernetes first. How much time it will take?
so I mean it's good that you have a tool which automatically does it and things like that. Because I
know some developers don't like it. Some developers will definitely like it.
I think the issue here is not how fast it is deployed. The issue is that the pain it takes away from maintenance, from the fact that you have to learn so many things to be able to do a change. So that way, this is nice to learn.
So if you want to deploy, you just need to like basic deployment. You just need to learn a new. In fact, if you move to a lot of new companies, they will provide a lot of new tools to learn, right? And so that will also, in fact, when you move to Amazon, you have to learn AWS a lot.
So that's one of the things. So when I was working at Yahoo, we were across the road. So Yahoo had their own YPKG, I don't even remember what it was. Some packaging system that they had built over here. When I was working at HP, they had their own ways of package management, and also has its own stuff to do all of it. And anyway, even today, this RPM sucks.
Any challenges with the authorization piece of it, like maintaining history of how this deployments happen, or any metrics that surround what anything calculated?
Like what? For a developer, you need like how to install, but having issues with.
Not really, like the usage metrics around what within your company.
Like everyone being run by SSO, so you know who's running what.
Yes.
So you have all this.
You can track the history. So and the if I remember, the most used command was bar deploy, and the second I guess second most is.
So if you how many people have their access and how many people have like they should be
authorization.
Yeah. So it is completely based on GitHub teams and the code owners. Okay, so which team you are in right now, and if you are in that team, if you are in that Google groups, only you can have that access. Either you need to be either your team needs to be a maintainer or admin access of that repo.
So basically, it depends on the hardware of that specific.
Yes. So you can't be deployed, go to some other team and do a bar deploy, and then you will able to deploy. It will eventually fail because you are not a part of that team. So like Bart also have some metadata where it needs to store some info like GitHub username, GitHub token, your Google group email or your email ID or whatever.
So in the backend, it's not just CLI, it has its own service.
Yes. And even when you do a BART deploy, it eventually is not like you just provide an interface, but in the background, it actually connect to a gRPC request to a gRPC service, and then that will hit to this service, the deployer, which actually do all those merging and stuff. Those are gRPC requests happening in the background.
So are you aware of anyone who is aware of any documentation which is extending ChatGPT 3 or the newer version of it for documenting? We have been using quite a lot for documenting a lot of stuff, even for data generation or simple programs. It has been doing quite well. So earlier using Swagger on functional level, it was generating quite decent API. If you can write the documentation as well, like the textual parts of it where you describe the output, and
don't manage ChatGPT, like you can do a lot of some using ChatGPT, but yeah, documentation or some. Well, the first thing, I think if you are in engineer, you should like not use any other tool to like Atlassian, Confluence and like product manager, they can use. They are not able to create a pull request and then they are not able to write a DB. But the engineer should not use this and you can build it together with this. The caution is very important.
What is the reason to use Golang?
Is why not?
I mean, we want to say they keep basically doing a small thing, they don't make a bigger picture. They have to make a bigger picture, then they have to do the tools.
Tools actually makes these things very simple. Like I must tell you that earlier when we were dealing with the condition and a lot of tooling, like now we just need to learn one skill, which is like describe the problem properly.
Yeah, you are working it.
Yeah, describe the problem properly. And in fact, if you can't describe properly, give one sample also that this is the input and output I'm setting, and then give the data so that it's really yeah.
Last.
Yeah, I will keep it short.
So when are you going to open source?